Hello, my physics students. It's Mr. Bozide again. Welcome to another flip video. Today we're going to be talking about two-body systems. I've got a couple examples right here. This example has a special name or a specific name. It's called Knatwood's machine. And all it is comprised of is a pulley with a string, and on either side of the string are some masses. Here's another two-body system, and this is just two blocks, right? And they're going to kind of interact with each other by pushing one against the other. So when I do that, we can think of this as a two-body system. And one of the hallmarks of a two-body system is that there's a connection between the two objects. And that connection really transmits the force from one object to another and back again. So for example, in this string, we know that the force of tension in a string is the same throughout. So that means that however much tension is pulling up on the object on this side, on the right, the same string is pulling up on this object on the left with the same tension. Likewise, when we push these two blocks together, however much force this block is pushing on that block with, well, this block must be pushing back with the same amount of force, right? Interesting thing about this is that when the two masses are the same on the Knatwood machine, well, gravity's the same and tension's the same. They're in equilibrium, they're balanced. But if I add some mass to one side, then that means that this side has more mass, and what we find is that it accelerates. We know when the forces are balanced, an object can either be at rest or it can move at a constant velocity. So this is pretty fun. If I give this just a slight downward constant velocity, we see that the one moves up with a constant velocity. They move with a constant velocity together because the forces are balanced, and that's, as we know, inertia. But like I said, if I hang a little extra mass on this side, then the forces are no longer balanced, and we find that it accelerates. Added more mass to this side, which is going to make it accelerate. And we see that happening right here. Okay? So we see them accelerating like that. In fact, something that's really important about two-body systems is that both objects have the same acceleration. And if you think about it, that makes perfect sense because they're tied together with a string. So however quickly this is accelerating down, whatever rate this is accelerating down, the other one's accelerating up at the same rate. Watch it one more time and just kind of convince yourself that they're accelerating at the same rate. There you go. We'll remember that for later.